Let's create a recursive subroutine that calculates the factorial of a number in assembly. You might be thinking, why not just use a macro like we did previously? Because macros essentially copy and paste their contents wherever they are used, a macro cannot call itself. Because if the assembler allowed it to, it would end up copying and pasting its value infinitely. If you're confused about recursion or factorials, watch my video on those topics. Let's start with our usual program layout and add a label for our factorial subroutine. This will allow us to use factorial code from anywhere in the program by jumping to and from it. The problem is, how does it know where in the program to jump back to? We can solve this by adding a return label after the jump command and pushing the value of the label onto the stack. After calculating the factorial, it will pop the location off of the stack and jump to it. Luckily for us, NASM has provided a cleaner way of doing this. Instead of adding a label after each jump, we can instead use the call instruction. At the end of each subroutine, we can use the return instruction to return to the caller. We have now officially created a subroutine. Unlike macros, subroutines do not copy and paste their value where they are called. This means we must store the arguments that it uses somewhere that it can access. For now, you should know that the standard for passing the first 6 arguments to a subroutine uses registers in the following order: RDI, RSI, RDX, RCX, R8, and R9. The standard location for the return value is in the register RAX. That being said, let's calculate the value of 5 factorial by moving the value 5 into RDI. At the beginning of the subroutine, we'll set up the labels for our base case and self-call. The subroutine will first compare RDI to 1, and will jump to the base case if they are equal, otherwise it will continue to the self-call code. In the self-call section, RDI will be decremented, meaning 1 is subtracted from it, and factorial will be called with this new value. After that subroutine call returns, RAX will hold the value of the result. We'll then increment RDI back to its original value. Next, we'll multiply the value in RDI by the returned value in RAX. The multiply command takes in one register as an argument, multiplies its value by the value in RAX, and stores the lower 8 bytes of the result in RAX and the upper 8 bytes of the result in RDX. For now, we will assume that we are only working with small numbers and ignore the contents in RDX. Because the result is in RAX, the self-call section is done. For the base case, we move 1 into RAX and return.